Hi everyone, I am Dr. Kiran Raavi, Assistant Professor in the Department of Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad, India. Today we start Unit 2 is about diode applications. Let us see the overview of today's session. Today we are going to discuss diode applications, introduction to power supplies, rectifiers, half-wave rectifier and summary. Diode applications. Particularly, diodes are used as rectifier in DC power supplies. They can also be used as switch in digital logic circuits used in computers. They are used as clamping network, used as a DC restorer in TV receivers and voltage multipliers. Clipping circuits used as wave shaping circuits used in computers, radars, radio and TV receivers. It can also be used in as demodulation circuit to demodulate the incoming signal at the receiver side. And apart from these applications, diode can also be used in different applications based on the doping concentration. So diode can be doped with different concentrations. So the same PN junction diode with different doping concentrations finds special applications as follows. Detectors, pin diodes in optical communication circuits, Zener diodes in voltage regulators, varactor diodes in tuning sections of radio and TV receivers, light emitting diodes LEDs in digital displays, laser diodes in optical communications, tunnel diodes are used as relaxation oscillator at microwave frequencies. Okay, so all these stuff I have had from Salivahanan textbook. So now let us go in detail about power supplies. So what is the main application of diode is? It can also be used as a rectifier in power supplies. So what do you mean by rectifier power supplies? So here all electronic circuits need a DC power supply from battery or power pack units. So here AC to DC, that means alternating current into direct current. So which is the network which converts this AC to DC is also called as linear mode power supply. Similarly, within the circuit, sometimes it has to be conversion from DC to DC. So the network which converts DC to DC is nothing but switched mode power supply, SMPS. LMPS and SMPS are the two power supplies, and the same way the network has to convert DC to AC within the circuit. So that is nothing but an inverter. So in computers we know we used to hear this UPS and SPS. UPS means uninterrupted power supply or standard power supply. So here you can observe the circuit diagram or block diagram of principle of a normal linear mode power supply. This represents the linear mode power supply, LMPS. So which required voltage reference, so error amplifier and control element, here sampling of the output. Okay, and finally you will find the output, and from the control to the control unit we will give input which is to be converted. Similarly, so on the right side you can observe the block diagram for the SMPS. See here voltage reference, error amplifier, so sampling network, oscillator, control unit and then control element output. So here in this case we will give unregulated input to the control element, and which converts DC to DC. Okay, so now let us see the actual block diagram of the main power supply. So here LMPS is the network which is linear mode power supply in which AC is converted into DC. Okay, so all the electronic gadgets cannot be operated using AC signal. So it required DC. So even though if you consider a computer motherboard, in this the main power supply is 230 volts, but this 230 volts cannot be applied to the each and integrated circuits within the motherboard, because each circuit required some less amount of DC supply. So therefore in the internal circuit we require some DC supply. So in such case we have to convert this AC signal, 230 volts AC signal, into required DC level. So that network is called linear mode power supply. So here if you observe, this is your 230 volts. For example, 230 volts will be reduced to some less amount of voltage using transformer. Using transformer, that's 230 volts will be reduced, and after that if you apply this voltage to a rectifier, so this is the pulsating DC, and again you have a filter to reduce the pulses or ripples. After that this filtered output is applied to a regulator. So here we have this is input 230 volts 50 hertz will be applied to a step down transformer, and then we will use a bridge rectifier. That bridge rectifier will gives you this pulsating DC, and this pulsating DC is applied to a filter, and this filter filters the ripples from this pulsating DC. Then you will find the DC signal, and from this it has to be regulated, the voltage has to be regulated, hence we have to use this regulator's circuit. Then you will find the pure DC, purest form of the DC. So this is the overview of a or block diagram of a power supply. Now how we can utilize diode as a rectifier in the power supply. So rectifiers is nothing but it converts analog alternating current into direct current. So based on the number of diodes utilized in the circuit, the rectifiers are divided into three categories: half wave rectifier, full wave rectifier, and bridge rectifier. Half wave rectifier is nothing but, in this half wave rectifier only one diode is used. In this full wave rectifier, two diodes will be used. In bridge rectifier, 4 diodes will be used. Okay. So today's session we will cover this half wave rectifier circuit. So let us see what is half wave rectifier. Half wave rectifier means it converts AC voltage into pulsating DC. It uses only one half cycle of the input AC voltage. So here we are giving this input signal, 230 volts input signal, to a transformer. This is a transformer. To this, the primary of the transformer, primary coil of the transformer is this. This is the primary, and this is secondary, and the primary and secondary coil. So to the primary we are giving 230 volts, and after that this transformer decreases the 230 volts, and at this point to the diode very less amount of voltage is applied to the diode. Otherwise 230 volts is not suitable for this diode. So diode cannot withstand this much amount of voltage. So now this diode here acts as a rectifier. Rectifier means this AC signal is converted into DC signal, that too pulsating DC. So after that pulsating DC, we have to use filter, and filter will remove the ripples or pulses from the rectified output. Then after that we have to use voltage regulator to get pure form of the DC. So this is your 230 volts AC, 0 pi 2 pi. And now, so after applying this voltage to a half wave rectifier, so what happens during positive half cycle of the input signal, then only the diode gets forward bias and diode conducts. So during positive half cycle only the diode starts conducted. That means closed circuit. So you can write like this. So here at the load resistor you can find the output. So this is a closed circuit, right? So here the current will flow like this. So during positive half cycle of the input signal, 230 volts input AC input signal, the diode starts conducts. The diode gets forward bias because this will be connected to positive and this will be connected to negative, means positive. The anode is connected to the positive, means it is forward bias. So during positive half cycle you will find you can get the output current. So therefore during negative half cycle, what happens? During negative half cycle of the input signal, the diode gets reverse bias because here negative is available. This negative terminal is connected to anode, means what? This is negative and anode is positive, means reverse bias. So during reverse bias, this act as a open circuit like this. So open circuit because of the reverse bias. So during negative half cycle, there is no current flowing through the diode. So therefore, hence the voltage will be 0. So this is the way of analyzing the operation of your rectifier circuit, half wave rectifier. So in this only only one half cycle of the input AC voltage is utilized. So remaining half is, so that is the drawback of this half wave rectifier. The efficiency is less. Okay, so let us see the summary for today's session. So we have started with diode applications. What are the different diode applications? Normal diode applications we have talked about, and then depending upon the concentration, doping concentration, the special purpose diodes can be used for different applications like LED, laser, SCR and so on. At the same time, we have discussed what is the power supplies. So how many power supplies we have, what kind of power supplies, LMPS, SMPS, and then UPS. All these we have discussed here. And then the main application of diode is rectifier, which converts AC to pulsating DC. And after pulsating DC, this pulsating DC is applied to a filter. So filters are again divided into inductive filter and capacitive filter, that we will discuss in the later classes. So after applying this filter removes these ripples in the DC, and then finally you will get the pure DC after applying the voltage regulator. So voltage regulator we have to apply here, then you will get the purest DC, and this DC can also be applied to any electronic gadget. So best example, best application of this rectifiers is mobile charger. In mobile charger you will have 3.5 volts is the output of the mobile charger. So and then we have discussed the half wave rectifier. Half wave rectifier operation and its input output waveform we have discussed. And the next topic will be the performance parameters of half wave rectifier. Performance parameters means what is the efficiency, what is the input power, what is the DC power, what is AC power. All these parameters represents the performance of a half wave rectifier. Okay, so today I will stop here. So remaining we will discuss in the next classes. Thank you.